Okay, take your places in front of the mirror.
We live in a world of light and images. Images that give us information about our world.
Hey, can somebody get the circuit breaker?
Light is a form of energy produced by energy transformations, like those from the chemical energy in batteries, or transformations from the electrical energy in a circuit. And because light is a form of energy, it can also be transformed into other forms of energy, like heat.
It's getting awfully hot. Can you turn off a few of the lights for a while?
Let me get a reading.
Or electrical energy in photoconductive sensors of exposure meters.
Okay, I can do it with this light.
Or light can be transformed into chemical energy. This happens on light-sensitive surfaces, like film, or the retina of your eye. These transformations create images, and images are what we see. But how does light create those images? We can find out by simply following light and seeing what happens to it after it leaves its source, and why that happens. But first, you need to get an understanding of light itself. That isn't too easy to do, since nobody really knows exactly what light is. We do know that it's a form of electromagnetic radiation. When it's transmitted through a transparent medium, like air, light seems to behave like a wave. But when it's absorbed by an opaque substance, like one of our dancers, light seems to behave as if it were made up of particles. Images begin with a source of light that emits packets of energy called photons. The photons move in waves through the air. Traveling in a straight line from their source, the waves of photons reach the dancers. The light waves reach the photographer and his camera. They reach the pitcher of water and the glasses on the table. They reach the mirror and the floor it's standing on. But the light waves don't directly reach everywhere. The mirror blocks the transmission of light and creates a shadow. The dancers block some of the light and create shadows too. The pitcher of water and glasses blocks some of the light, but most of it gets through. In each of these cases where light is interacting with objects in the room, light has arrived at a boundary between the air and another medium. In each of these cases, different things happen to the light. That will eventually make it possible for the light to enter the photographer's camera and his eyes and create images. Some of the light that strikes the dancers is absorbed. Its photons give up their energy in the form of heat. But most of the light is reflected. The waves bounce off the irregular surfaces of the dancer's skin and hair and clothing. If we think of the incoming waves in terms of photons, a group of photons that moved in parallel paths before being reflected would not be parallel after reflection. This is called diffuse reflection. The angles at which these light waves are reflected are directly related to the texture of the surfaces reflecting the light. The smoother the surface, the less diffuse the reflection. A very smooth surface like a mirror reflects light too, but not diffusely. Let's think about that wave of photons moving in parallel paths that we looked at before. When the photons reach the boundary between the two mediums, the air and the flat, smooth surface of the mirror, they are reflected in a regular way back into the same medium and move away from the mirror in parallel paths. Sometimes, when a light wave comes to a boundary between two mediums, most of it isn't absorbed or reflected off the second medium, but passes through it. Clear glass and water are transparent, like air, but denser, and things can look different through them than through air, and even more different through water. Light changes speed as it passes from one transparent medium into another with a different density. When a light wave enters a denser medium at a right angle, all the photons change speed together, continuing in the same direction, but slowed down. But when the wave comes in at an angle, it slows down one photon at a time. This causes the wave to change direction. The bending of the light wave is called refraction. Light waves are refracted anytime they pass at any angle other than a right angle between mediums of different densities, and that distorts what we see through them. When the reflected and refracted light waves finally enter the photographer's camera and eyes, images will be formed. It happens like this. All the photons in these light waves traveling through the air of the room move in straight lines. They follow their straight line paths to the camera and into it until they arrive at boundaries of mediums with different densities. This happens inside the camera when light passes through the lenses. The lenses are much more dense than air, and so they change the light wave's directions. Concave lenses spread light waves. Convex lenses cause light waves to converge. In this camera, a combination of concave and convex lenses refracts light waves to bring them to a focus on the film. These light waves entering the camera have been reflected from an immense number of tiny areas on the illuminated objects. Light waves from these countless areas, collected and brought to a focus on the film, produce the chemical changes that create the images we see. How permanent an image will be depends on whether the chemical reactions that form it are reversible. They're not reversible on film, but they are in your eyes. Light enters each of your eyes just as it enters a camera. The waves are focused by a single convex lens in each eye onto a light-sensitive surface, the retina. Here an image is formed, which causes the cells of your retina to send electrical signals to your brain, and then you see. Seeing is really done in your brain. The images formed on your retina aren't permanent, as they are on photographic film. In your eyes, an image lasts for only about 1/16 of a second. This brief persistence of vision makes motion pictures and other similar processes possible. For instance, your persistence of vision makes you think you're seeing these dancers in continuous movement. But the motion you see is only an illusion. All you're really seeing is a series of separate, still images. But the images are moving so fast that they blur into one continuous action. So, light waves are produced by an energy transformation. They move out in all directions. They're refracted when they pass across the boundaries between transparent substances of varying densities, and they're reflected off a variety of surfaces. And finally, if the light waves are absorbed by a light-sensitive surface, and if the focus is right, we get images.